Hey guys, welcome to today's webinar and thank you for joining the session. My name is Isabella and I'm from OPTUM, and we are happy to welcome you to the third webinar in our series. Today's topic is Python scripting and GX plugins. It's a session that really shows how you can automate a lot of your geotechnical workflows. And we have two more sessions coming up before Christmas. Next week we have consolidation, and that's on Wednesday. And on the Thursday after, on December 4, we have foundations. And tomorrow I will send you a link with the registration links if you want to sign up for the next two webinars, and also a link so you can rewatch today's webinar as well. The speaker today is Christian, and he is the partner here in OPTUM, and is really good at explaining Python, so you are in good hands today. So feel free to post any questions in the chat, and we will get back to it later on in the towards the end of the webinar. And now I will hand it over to you, Christian.
Thank you, Isabella. Yeah, and welcome. So I think we will. So we have an hour today, and Isabella mentioned two topics: Python scripting and GX plugins. And let me just share my screen. And I think that is too much, probably for 1 hour. So today is going to be more an introduction to the Python scripting, and then we will have a session in some time, maybe probably early next year, on actual plugin development. I'll say a little bit about it today, but it's not going to be the full session on that. There's more to be said about that, actually. But so Python scripting. I had some slides that I hope I could start. Okay. Why can't I start my... Oh. That's a bit weird. You can still see my screen, Isabella? Okay. I don't know why I can't start my slides. Anyway, you can see the slides here, and there's not a lot of them. But so Python scripting, it's something that's really quite powerful. So what is a script? A script is a small program, essentially, with some commands that basically do something equivalent to what you would normally do with mouse click on the screen, in the UI, in GX itself. So draw some lines, draw two lines. That would be sort of two lines of code. First draw one and then the other. And so the idea is that everything you do with mouse click, you can do with scripting commands issued in Python. So why would you do that? Well, you would do that if you find yourself solving more or less the same problem with some variations all the time, then it might be a good idea to have a script to basically generate your problem and possibly also even solve it, and maybe even extract results and then do some post-processing of those results. So it's ideal for parametric studies and automation as well. I have some examples of small apps or plugins, we call them, that we have developed. And these are shown up here. The first one here is sort of an internal one that's not available to everyone, but the rest here are examples of plugins that we have developed here in OPTUM and that are available to everyone. So they do various things. This one here takes converts a DXF file to a GX model, so like that. and the others do other sort of small tasks, smaller or bigger tasks. These are not that difficult to actually develop. All the source code, I should say, as well, for all of these plugins is available. There's nothing secret about them. You have access to exactly the same as we have here in OPTUM. You can open the plugin folder like that, and then you come to the plugin folder, and here are the Python files. Go one level up. This is basically the plugins, DXF import, and so on. So this is where you would want to put them. But I'll return to that a little bit later, how exactly to do that. You can access, so you can define geometry and define the problem, apply loads and materials and so on. And you can also access, after the calculations are done, you can access the results and either to view them or to sometimes it's useful to do some, or necessary even to do some post-processing, code checks and the likes. That is not included in OPTUM GX necessarily. You would want to extract the results and then process them yourselves. So the way it works is that we are working with Python. So all the functionality of Python is at your fingertips, and then there are some extra commands. Basically, there's a Python, there's a GX Python module that then it gives you access to specialized GX commands that are necessary basically to control the user interface. We sometimes talk about remote control of the user interface as well, because that's kind of what it is. But before I get into an actual example, this is how it's going to run today. I'm going to run through some examples so you can see how it works. I just wanted to mention the sort of the fundamental basic principle, or one of them, of the scripting language. So we have sort of 4 levels, you could say. We can start, if we start from the top, with what we call the application. That's the program itself. So there are that's the highest level, where you do things like opening a project, save a project, and also create a project. So when you open up GX, a project is automatically created, is already there. But if you want to create a new project, well, you can do that, and we'll do that in a second. That's basically what happens if I press the new button here. So that's at the very highest level. So we have an object called, we usually call it GX, but it could be called anything. And so GX dot open project or GX dot create project. And then once we have the project object, let's call that PRJ, then we have the project level. This is where the materials live. So the materials are global. They don't apply to any particular model or stage. They're global, right? So they live at the project level. Create a model, that's basically what we do when we press one of these buttons here, or clone a model. That's also something that adds to the project. So that's the project level. Run analysis, pressing the button here, processes all the models in the project. Then there's the model level, and this is where it comes. This is where we define geometry and apply materials, set the analysis properties. Is it limit analysis? Is it deformation analysis? What is it? All these things is at the model level, or possibly under models we have stages as well, right? For those of you who are aware of that. So there's sort of 2 ways of working in OPTUM, with models, with independent models, or you can have stages under models. So that's the basic principle. So an example here. So the first line here, this is basically, this establishes connection to the user, to the program, to the application, as we call it. And then we call this object GX, and then it's GX dot create project. We call this project the resulting variable, we would say, that comes out of that is called PRJ. And that has some functions attached to it. One of them is create model. So create model, model one. Then we call this model object mod. And then we can add a line there. So that's sort of how it works. But I think it's better to see actually live in practice. So the question is, how do you get started with this? And I think the best way to get started is to use the inbuilt Python IDE. I believe IDE stands for Integrated Development Environment. This is a relatively primitive sort of editor. And over here we have Python running. So this is the Python command window. I always do 1 + 1 just to make sure it's alive. And it seems to be alive. And here is then the script that has all your commands, a mixture. Here's mostly GX specific commands, but it could be a mixture of Python and GX specific commands. So this is the introductory example. But if we were to start, sort of to demonstrate, I thought about what should we do, and I thought about let's do a slope, because it's something that I think we could actually just maybe continue with this one here. It's always good to do just a minimal amount of planning on paper. So if I was to do a slope that looks like this, I think I would rather have these be white. You know, so white, and I think they should be a bit thicker as well, like that. A slope like that, and I would then call this one I would call the height. And I am going to start actually, because this is getting a bit annoying with these colors. Let's start over with an empty presentation. A slope like this, and then a slope has a height h, and it has also, there's an inclination. This angle here, we usually call that theta. That's what I call it anyway. And that's a Q, and then I should change to symbol like that. I would like a script that sets up a slope with height h and angle theta, and then we can have the parameter, the soil parameters. Let's just say it's a more Coulomb, so it's C, phi, and gamma. That's my that would be my parameters, my soil parameters, and then do a factor of safety analysis and report the result. So how do we do that? Well, this is where I said a little bit of planning is kind of necessary, because we have some points, and we say we have a point down here, we have a point up here, and then we need to sort of kind of create a the usual kind of rectangle, right? And that needs to be supported as well. Not rectangle, but so kind of a polygon like this that needs to be supported. We have these points, some more here, and here. And then just to make sure that we know what we're doing, let's call this one, say this is 0, 0. Then this one up here will be what? I believe it will be h divided by tan theta, comma, the height is h. And out here, we could then say, how far are we? We could say something like 3 times h, comma h. And here we could say 3 times h, comma minus h. And this one here would be maybe minus h, comma minus h. And this one here minus h, comma 0. So I will start by defining basically these points and then draw lines basically that define this polygon. That's the idea. So how do we do that? Let's start with a new one here. And when you start a new file in this, it already comes with this GX equal to capital GX. So now we are let's see if this runs. Now we are in touch with GX, basically. Now we can start issuing commands and things will happen at the user interface levels. And the first thing we want to do is create a project. And that's GX create project. And we can call it slope. And then we have the project, and then we want to create model. And let's call it factor of safety, FOS. Let's try to see if this runs. And it does. It's created a new project. It's called Slope, and then it's added a model in addition to the default model A. You can also delete that if you want, but let's just leave it. And we have a new model here called FOS, and that we then need to do something about. And the first thing we need to do is define create some lines, basically add some lines. Let's do that. So I call it P0. That's the first one. And that is, I like to use NumPy. I don't think it's not really actually necessary, but NumPy is a standard sort of Python module that is useful, that kind of gives you MATLAB type functionality for arrays and for matrices and so on. So I quite like to use that. It's not strictly necessary, but it doesn't hurt either. So, and P1 is then was this one here. Let's say, let's go clockwise. So that is 3 times h, comma, no, P1, sorry. It should be this one here, of course. So that is h divided by, NumPy has also the tan function. So let's call this theta, and then comma h. And then we can already see we need to first, let's say, define the parameters. So we can do that right at the top. Parameters, and let's say h, 10 meters, theta is 30 degrees. Let's actually call this theta degree, and then say a theta is, because this tan expects radiant, like that. Move that down, and we might as well, let's say c is 10, phi is whatever, 30 degrees, gamma is 18. We have those, and then this one here. So that's our parameters. And so on with the points, P2, MP array. And that was then the 3 times h, comma h. And P3 is 3 times h, comma minus h. P4 is those 3, 4 is this minus H comma minus H. And P5 is minus H comma 0. That should give me my 5 points. Oh, 6 points it is. And then I'll say yeah, I haven't named my model. Let's just call it M. So when I create a model, I would like to refer to it later on. So let's call this model M, this model object M. So then I can say M, add line, and P0 to P1, and 1 to 2, 2 to 3, 3 to 4, and so on, 4 to 5, and then back to 0. Let's see if this produces something. And it did actually produce something. It produced a slope that looks like this. And it looks a little bit, I think it became a bit too deep. So that's the minus H here. You could say, let's say divided by 2. And then maybe it became a bit too long here. That is this H here, we can also divide that by 2. We'll sort of have a reasonable looking geometry. That's probably pretty good. Probably not too bad. Let's say 1.5. Okay. Then materials, and as I said, materials is a part of the project. Materials are part of the project, so we should probably sort of define that up here. And I'm going to call it soil, and then I'm going to say that is a project property, and we have a function here called more Coulomb. And that has then a whole lot of parameters. And what are those? Well, you can go over here and then you can say help more Coulomb. So here you see all the parameters that we have. So they're called E, new, C, phi, and so on. We have tried to stay as close to the user interface as possible. So the variable E here that's shown as E in the user interface, the Young's modulus, it's also called E in the Python scripting language. C and phi, same kind of thing. So it shouldn't be too mysterious what things mean, but there is full explanation here. The help function is pretty good. And we also have online, I can just show that at optumg.com, resources, and then there's knowledge base, and under knowledge base there's Python docs. And here are all the functions sorted by the application is at the top level project model. Model is where most of the functions are. You usually operate on the model level. So add polygon, actually we could have used add polygon in this case, rather than add separate lines. We could have sort of just used the polygon to define the geometry, and they're all here with all of them come with examples that can be copy pasted straight into Python. But so here's an example also of the use of the more Coulomb material. So it starts with name, and then there's one with the ones we need really is C, phi, and then gamma dry is what we're gonna set. We are not gonna have any water involved here, so it's gonna be the gamma dry that's gonna be used in the actual calculation. So first the name, let's call it, let's call that, could be soil as well. Call it MC soil. And then C is, I've called it C up here, so C equal to C, phi equal to phi, gamma dry equal to gamma, and then color. And we can either do, as is shown here, sort of RGB, or we can do just write, if we write green, there's some predefined colors already. So you can do it like that. And just to see if this works, I recommend sort of going step by step, not writing a whole script and then executing it, and there'll be many times lots of errors. Sort of run gradually to make sure that everything is fine. So that was this one. Why it's called Moculum 1? Okay, it's because I forgot to say name. So then it picks a sort of a default name. Now it should be called MC soil, yeah. And I have C10, 530, and gamma 18. That's what I have here as my parameters. And then in the user interface, the way we would apply a material is we would select this face and then, apply the material. And through Python scripting, it's much the same idea. We need to first select the face and then apply the material. It's in that way, it is really is one-to-one. So we have to do a selection. So I say M, that's my model, and then there's a function called select, and I then need to specify, can either be just like a single coordinate, which corresponds to like a mouse click, or it can be a box like this, either a green or a blue box. But I'm just going to supply a coordinate, and the coordinate I'm going to supply is actually 0,0, which is right on the edge, but it will work. It will do fine here because we also have to specify the types of geometric objects that we are selecting. And in this case, it's face. And that's it. Then I have my selection is called cell, and then I can say m.set solid. That's basically setting a solid material. And what I need to specify is the selection, the face that I've just selected, and then the soil or the material, and the material up here, I called it soil. So first I select the face, and then I set the solid, set the material to that face. Let's see if that works. It seems to work. And at this stage, you kind of feel like also doing a zoom all. So we can see the whole problem when we run it like that. And then what we would typically do is we would press the standard fixities button, and in Python, the equivalent is at the model level, set standard fixities, like that. And the supports are now applied. Then we have to set the analysis properties. The default one here, when you open up the program, it's mesh, and that's not exactly what we want to be doing. We want a factor of safety with some specified number of elements and etc. Adaptivity, yes, no. It's called set analysis properties. And again, I'll copy this and paste it over here and do a help, because I don't remember exactly how to set those. So help gives me actually examples of the different analysis types we have. So starting with mesh, initial stress, and so on. And what we are looking for here is the analysis type called factor of safety, this one here. So if I just copy this and paste it into here, I'm actually up and running. So analysis type, factor of safety, Gauss, element type Gauss, I like to use mixed. Number of elements, 1000. Mesh adaptivity, let's just try with no to start with. Adaptive iterations, that's not really relevant, but let's say 3. And start elements, let's say also 1000. Adaptivity control, it's better to stay with the default, so we can just delete that from model, from stage. It's not really relevant here. Design approach, you can also pick that. For the rest here, let's just use default parameters. So like this. So 1000 mixed elements, no adaptivity, and then you should be more or less set up. So you're set up like this. And then it's a question of going to the project and say run analysis like that. And then basically the problem will run. And just to check that it sort of makes sense, let's just try to plot this one, and it seems to make sense. 1.68, the factor of safety. Now, you would then want some output as well, typically. I mean, at least the factor of safety. And that output lives also under the model. And I'll write here, if I write M output, I get, it's not shown everything here, but there's one called under output here, critical results. Critical results. And one of these so-called critical results is factor of safety, which I would like to have like that. So, and I can then do a print. Well, I can actually say FOS is equal to that, insert that into my script, and then say print FOS. Or we could even do like this, plus and then a string. So this is Python. And then it should print it out over here at the command prompt, which it does. So the advantage of this, of course, is that if you have a different angle, well, then it's much easier to change 30 to 25 in a text editor rather than having to alter the geometry with mouse clicks and with editing the geometry and so on in the UI. There's also the possibility, you could say, that if you want to have the factor of safety for a range of angles, if you want to do sort of parametric analysis, well, then you would, one way of doing it would be to just put a loop around. So you could say, let's say we have just a theta array. So 25, 30, 35, 40, let's say like that. And then we say for I in range length theta. And then we need to indent all of this. And then we can say in each time we run through the loop, theta is this the ith entry in the theta array, and then we basically do the same thing, in this case 4 times. Let's just see if that runs. And of course, at the end of each, every time you have a result, you would sort of want to collect those. I'm not sure why it doesn't print out over here, but maybe it comes right at the end. Yeah, okay, so it came right at the end. That's sort of a peculiarity of this IDE. So the factors of safety for, what was it, 25, 30, 35, and 40, and it decreases as you would expect. You could also add a model every time you have a new theta, so you'd have all your models here that you could inspect afterwards. It's really up to you how to do it. There's full flexibility in that regard. So this was a sort of a little example of how to get started, you could say. There is also the get started file here, script, which is I believe a strip foundation like that, and where you also have adaptivity in play. So this is maybe a little more involved. There's two materials here, the soil material and then the rigid material that is used for the foundation. And the geometry is sort of more or less the same kind of level of difficulty, you could say, complexity, which is not very complex at all. Here we also set some, it's a surface load, so that's the load on top here. We have M set surface load. As usual with Python, if you want to know what functions are available, you do M, that's the name of the model, and then dot and tab, and then you have your functions here. So if you are looking, how do I apply load? Well, I mean, you can sort of, you can find it here. It's also possible, I believe, here to do a search. If I just say load, yeah, set surface load, that's what you want in this case, and then the documentation is here. So it requires a little bit of practice to get into, but I think the documentation is pretty good. And as I said, we have tried to make this, as you could say, as user-friendly as possible. There's no weird, we think, no weird sort of syntax. Things are called more or less what you would expect them to be called, and are as one-to-one with what things are called in the user interface as possible. These are actually called surface loads, right? So so that's how that works. I wanted to just say a few words about these plugins that I started with, because what you can do is you can take a script like this, like the one we just created, and then basically attach it to a simple user interface that is also programmed in Python. And then end up with something, for example, like the one shown here, we call it Spooks. And it is a small plugin for basically setting up a embedded retainer, sheet pile wall it is. So where you enter the ground level, excavation level, tip level, and some wall properties, the load, there's some possible surcharge up here at the top, and then there can be something with groundwater as well, the groundwater level at the front and the back of the wall, and also there's partial factors that you can apply as well, and you have various options. You can either just generate the geometry like that, which is a lot easier than obviously than going through mouse clicks and generating this geometry. I've stopped actually doing that. I do quite a lot of retaining wall analysis, and I've stopped defining the geometry manually. I use this little app here. You can also do a factor of safety analysis. So in this case, actually, it's not very stable at all. And we should probably add another anchor. So you can do that here in this anchor tab. You can insert an anchor, call it anchor 2, and that's at level, let's say 15. Inclination, let's just stick with 30 degrees. Free bonded, and capacity, it was not a very high capacity either. Let's just also try to increase that, and spacing. And then let's run it again. That helped somewhat, but it didn't quite get to 1. So let's see what happens. The anchors are still sort of too weak. Maybe if we change the inclination of the anchors from 30 to 20, then it would be better. Again, these kinds of changes can be kind of painful to do in the user interface. So with an app like this, so yeah, now we are just stable. And there's also the final one, the possibility of, it's called tip level, where you iterate. Basically, you run through factors of safety analysis and adjust the tip level to get to a factor of safety of 1. Now it's almost 1. So this, I don't think, should require too many iterations. Let's just see what it gives. So I hope you can appreciate that this is a lot more, this is a lot faster to work with a small app like this than doing things manually. That was in which decreased too much, I guess. So now it will have to increase a little bit again. So yeah, so it stops. There's a tolerance, I think, of 0.01. So it stops when it's within 0.01 of a factor of safety of 1, which is, in this case, was slightly below 1. So that is entirely possible to do, to create these apps. And as I said, we will have a session soon about exactly how to do it. But if someone would like to get started already now, what I would recommend is the following. I'd recommend that you go into the plugin folder here. Maybe the latest one we have got included in the program just today is this one. We call it OPTUM GX. And it is an app for it's a 3D app for analyzing suction buckets. So you can either do a single capacity analysis, or you can generate a VH diagram. Again, a task that requires repeated calculations, and where some sort of automation is really a good idea. Have the soil profile where you can enter your parameters, and then eventually I had and there's also the possibility of including a so-called trench. Yeah, let's just do a single run, single capacity analysis, where the geometry is set up, and the geometry with this trench, doing it by mouse click, it can be done. I know that because I did it myself. That's typically how you want to first do it, and then say script your way through it. At least that's how I work. But it's a fairly tedious thing to do. Whereas with the scripting, well, it's not really very difficult at all. Oh, did I go for a VH diagram here? Yeah, okay, I went for the VH diagram. That was a mistake. So now it runs through basically these values of the inclination of the load, and then there's a V and an H. vertical and a horizontal force, and it eventually creates a, oh, okay, so there was a problem here. This problem is actually not stable at all due to the trench. So there's that to be sort of taken care of as well. So it actually collapses before any load is applied. So well, that's how it is. So this is our latest one. So we are learning all the time, and we are not really experts in this. We gain quite a lot of experience. So with every new app, we have more experience. And the latest one here is this suction bucket app, Spanx, where if you open the plugin folder, you have all the source code available. And I know the main one here is called Spanx. So for these types of developments, I would strongly recommend either Spider, which is what I use myself, or VS Code, which I know a lot of people use as well, rather than the inbuilt Python IDE that I showed you before that we've been working with so far. So Spider is, I think it's pretty good. It sort of has kind of a MATLAB feel. And I used to be a big fan of MATLAB. I kind of still am, but now it's Python. So this is as, I think, as close to MATLAB as probably you get with Python. And yeah, I think it's already open, but let me just close it. And let me open it here. So this is the main file that I can then also start from Spider. So I can run the app from Spider. I need to be in the right, I need to have the right Python interpreter. And then I need to shut this down. Just restart that, and then I can actually start it from Spider itself, and I have the full debugging functionality as well. I don't know why it's not starting up. Maybe it's a bit, oh, here it is. So whether through Spider or through GX, it's the same thing. So for debugging, this is definitely the way to go. Either Spider or VS Code, and how to set things up with these two. You have it here. Let's see, Python setting up IDE. So there's Python scripting with Spider. There's sort of a detailed guide for setting things up, and there's some troubleshooting as well. And so I can recommend going through that and an example script that should run. So that is what I recommend. But and then if you want to create your own app, basically the way to go about it is I would take a copy of this, and then yeah, that was not exactly. Just delete that again. I would say let's do a new folder, as a new plugin. And then I would take all the files here except these two. It doesn't hurt to take them, but it's not necessary. Just copy those into new plugin. And when I then start up GX again, there is going to be a new icon up here. There's going to be two of these. So this is the new one, and this is, or vice versa. I don't know. I should, of course, change the icon. The way it works is that this is the critical file, OPTUM spec. So this file, first of all, what is your main file? What is the Python script file that should be launched? What is the name of it? Description, what icon do I want? It's SVG, I think it can be PNG as well, but that's this icon file here. And then requirements. So these requirements are the Python packages that you use. There's some in the beginning here. This one is mandatory, but NumPy is, I use it here. This PyQt5 is basically what we use for the user interface. Pandas is used here and various other packages. So these packages are installed and put in what is called a so-called virtual environment. And that's the large file the large folder that I didn't want to copy. This virtual environment folder is created the first time you start up the app, meaning that the Python modules that you specify here are downloaded and put in this folder. So it's NumPy 126.4. I think there's a newer version of NumPy out there, but this is the one that is used for this app, and this is the one that's going to be used for this app forever. So things that were working today are also going to be working in 10 years from now. Doesn't matter if NumPy comes out with a new version where things have changed, you are still in the app using this particular one here. So I think that's a good thing, that sort of future-proofs your apps, because with Python, the problem is always that the modules are kind of updated on a regular basis and things are not necessarily the same as they were in the previous version. So that is a way to get started, and yeah, much of this code is self-explanatory here. So most of our apps follow a kind of you could say a template where we have some controls, some widgets they're called here on the left, spin boxes like this one here, combo boxes, these are called, and buttons on the left, and then on the right we have various tabs where we have this is a matplotlib plot. This is a combination of matplotlib and some sort of table. Collapse mechanism, where eventually the 3D collapse mechanism will be shown, it's called PyVista. It's sort of a 3D plotting module based on the VTK. It's really good, very fast. VH diagram, again matplotlib, and then a table with the data. So over here, yeah, you see this is the widget, spin box, diameter spin box, length spin box, and so on. So I think this should be pretty self-explanatory and not that difficult to get going with. Then the different tabs, or do they come? Yeah, here the different tabs: geometry, soil profile, and so on. And we have developed some functionality basically for, there's one called OPTUM Matplotlib, PyVista, soil profile, that's this tab here. And there's also one called widget utilities that allow you basically to create these widget spin boxes and what have you with a single line of code. So I think there's quite a lot to get going with, although we will, as I said, have a more detailed session on it later on. But for today, I think that's all, and I'll be happy to take any questions there may be. Yeah, it's a good question. Very good question. Is this scripting tool based on a particular Python version, for example, 3.12? Yes, it is, but this Python version comes with the program. It's 3.11. We are using 3.11. So it's at least 3.12 now, maybe more, the latest one, but we are using 3.11, and that is the version of Python that we recommend be used. It will probably work on 3.12 as well, But when you run through the Python IDE here, you don't have to have any Python installed. That's the first. Oh, I don't know why this is still open, but that's the first point I just want to make. Is that, let's just start up OPTUM again. With this inbuilt Python IDE, it works out of the box. You do not have to have any Python installed at all. And same actually for Spider and VS Code. So usually with Spider, and at least you sometimes if you use an Anaconda, then it comes with a it's sort of bundled with some version of Python, which is usually the latest version of Python. So I have 3.12 running on my system, but the one actually used, and you'll find that on the web page for setting up the IDE, the Python interpreter actually used is this one here. So you need to if you go through the this setting up IDE, then you will find out how to set that. I can see the images here are not fantastic, but basically here. So the short answer is you do not have to worry about Python versions at all. OPTUM G2 Python scripting is not available for OPTUM G2, no. And OPTUM G2 is a fine program, but I would strongly recommend switching to GX. Both, definitely if you're interested in scripting, GX is the way to go, but GX is also rather more powerful than G2. Even if you don't use scripting, it's faster, it has better all-round functionality, it has 3D, of course, as well. So if you're still using G2, I would recommend having a look at GX. All right, I think that was all for questions, and we are right on time. So thank you for your attention, and hope to see you again next time. Bye-bye.